Hey, I wanted to show my software. So this is unfortunately unable to show on Zoom, so I just wanted to show from this camera. So this is what it looks like filtered. This is what I did so far. And then this is the regular scan. So as you can see, it shows up on both sides right here. With filtered, it only shows 180, so a little bit over here from what we should see, and then shadows are filtered out. I'm not really sure why yet, but it will if I turn this around, which is the object mapping. It will do 360. I'm kind of thinking that the object in question, or the device I'm using, doesn't have like a proper gyroscope or something, but this is what it looks like. And I'm going to go over a little bit of the code. There's a lot of code to go over, so just wanted to get right into that. The code for this is using both a .yaml file and a .launch file. So .launch files uses XML. .yaml is just in that YAML format. And what it's going to do is it's going to read this YAML, so the YAML code. So this YAML code lets it know this is the variable, and this is the parameters for that variable. And there's two variables that it gives: shadows and then dark shadows. The launch file reads that from, let's see where it is. It should read it right here. So it loads the file right here. It loads the YAML file. It picks that and it uses that to filter, and I believe it should have the node right here. So it remaps it from scan to base scan. Base scan is the initial variable that it uses up here. Let's see. Right here. Scan and then base laser. So base scan is that final variable that it uses to filter all of that out. And this is part of a bigger project. So this is going to have a lot of files. One of the things that I'm doing is I'm kind of making my own files for this, but it doesn't work if I just take it out and make my own package. So there are quite a different load of variables that are already used by the Lidar software. RViz is a Linux software, and all of this from my last project, if you heard, is in Ubuntu 21.04 or 20.04. My apologies. And that's the version that I'm using. And I noticed that if you're on a newer version like 21.04 or 22.04, Ubuntu doesn't really like the software development kit that you use. So what I'm going to do is I'm also going to show you the terminal code that I'm pushing. So there actually is a lot more even from last time that I was using the bridge. So as always, if you saw my last video, you use the ROScore service. So you go up here and then you just type out ROScore. That just starts your computer out as the server for the software development kit. The Room Explorer, as you can see, I did push out a cat can make. You do need to basically resubmit this code. That's kind of like resubmitting your code over and over again, is the cat can make. Here, let's see if I can find it right there. That what this does is it looks at the package, it removes all of the excess packages, and then it starts building from the C++ files you have and the .h files, and then it just compiles it into one code for this to work. Once we have that ready, I loaded the parameters are actually needed to load differently. So you'll need to go into this location. I had to go into the launch file, so cd launch, and then you do rosparam load laser config.yaml scan to scan filter chain. Noetic does have the scan filters. The package is a little bit different than others, so this one has scan to scan filter chain, scan to cloud filter chain, and generic filter node. What I'm only using in this is scan to scan filter chain, that node from the package, and you'll load the YAML file that I showed previously right here, and you'll load that with the scan to scan filter chain node. So once you run that, it told me that the remove shadow start point is false, which I'm not super sure what that means, but if I had to guess, it would mean that it doesn't have a starting point, which would explain why rotating this kind of confuses the device into thinking that the 180 max angle doesn't apply anymore. Because as you can see, the RViz kind of shows it only showing one part. But if I even move it a little bit, it'll show the whole 180. It looks like it's only showing one half of that 180, so maybe it's still working. Maybe I'm the one confused. But you're going to go to scan, and then as you can see, it shows that full degrees of freedom in scan. So that one isn't filtered. That's the one that I didn't program, but I guess I programmed a little, but I didn't mess too much with the files. But once you upload the YAML file and then you use rosrun laser filters, laser filters are just the package that I was showing earlier right here. Then it will run that YAML file along with that gives these parameters of that angle. And then finally we get to actually run the RViz software. So what you'll do for that is roslaunch IPA room exploration test.launch. Test.launch was the file that I made, so I'm just going to go into that a little bit longer too. And within this file, what I did to make things a little bit easier for me is this file starts right up with RViz. If you want to know the command I use for that, I just use one node. I just call for RViz, and package, type, name, all the same. And then the arguments is you want to find that within the Lidar Noetic package within ROS. And then required, I said true. So that parameter makes sure that this is brought up immediately with it, which also means that if I close this, which I could probably do right now, then you should see right here, it killed it. So that will kill the program, because it needs to run with RViz. I labeled it as required. The rest of it is trying to figure out what the device is. So the arguments like this right here specifies where it's located. The 00.18 was the port I'm using for my computer. And then this is the type of LiDAR it is. That is actually pretty important. I know I thought it was like LD21. So even just that small little number, like it's a little bit less updated, even that won't work. And in fact, let's show that right now. So LD21, if I pretended like that was the one I wanted to run, and I'll launch it up again, as you can see there's nothing because it can't detect what that is. So you need to be exact with the labeling of your device. Like I said, it's a little bit tricky for me, but if you get a 360 mapping device, I would hope that it has the exact specifications, and it should have a little bit of documentation for what you need to name it. But this is the package that it's using, the IPA room exploration. I'm going to leave the GitHub as well with that. I forked the GitHub and modified it. And then this was something that I was going to do later. Turns out I think this is the code that actually I'm not using, but this also had kind of a nice little tutorial of filtering. I chose a different route of filtering, which is just using my own code. But yeah, that's the basis of how it's mapping out rooms.